So we left off on problem 8. 3. So we're looking at page 142. Says, which of the following numbers could be lengths of the sides of a right triangle? Well, you know, on a right triangle, maybe I better turn it on. I don't know why you guys can't see it. So if you have a right triangle, then you're going to use this thing that c squared equals a squared plus b squared. And a and b both have to be smaller than c in length. And so what you do is you just take, like for the first one, you take the sum of the two smaller sides, 11 squared plus 60 squared, and then you see whether it's equal to 61 squared. So you have so you just go 11 squared plus 60 squared and then go 61 squared. When you see they're equal, so that's a right triangle. Because these two are equal, then it's a right triangle. And B, you're just going to do the same thing, except you're going to do 8 and 9. You'll do 8 squared plus 9 squared, and then you do 15 squared. Find out what those are. And you notice they're not equal. So these is not equal to that. And it's not a right triangle. And then you do the same thing with C. It says, given the lengths of the sides of the triangle, indicate whether each triangle is a right triangle. If not, specify whether it is acute or obtuse. So, you're going to do the shorter sides, so it's 70 and 54. And let me and you can see that they're not equal. It's not a right triangle. So what we have to do is we have to identify whether it's acute or obtuse. Now, what it indicates to you, because 8100 is larger than the 7800, then the longer side creates let's see. It's an obtuse triangle. Because this side, this is the one that is the 90. And I didn't draw it right. One of these is 70, the other one's 54. And it would have to be that way. And problem 11 is telling you that there it says a triangle has sides A, B, and C where A is less than B is less than C. Consider the relationship A squared, B squared, and C squared for each of the following questions. It says when the triangle is a right triangle, when the triangle is acute, and when it's obtuse. And if you go through that problem, proving that shows that when you have this one being larger, like it was, and I don't know what this other one, I don't remember what it was, 78 something.
7816.
Yeah. That makes it obtuse. Because this angle is greater than 90. So B. And then 65 squared. Now then that one's a right because they're equal. This is a right triangle. And C is 24, 48, 52. Now you can see that the 52 squared is less than the sum of the other two, 28, 80, 50. And this makes this an acute triangle. So that's going to be the difference in how you evaluate those. It says find the missing lengths of the triangles. So A part. we have this one is 45 degrees. This is 45. Now, they're giving this 9. Well, in a right triangle that has 45 and 45, the two side legs are equal, so this is 9. And then the ratio, there's that theorem that says you either do this kind of ratio. Either the ratio is 1 to 1 to the square root of 2, or you can do it this way. 1 over the square root of 2, 1 over the square root of 2, and this is 1. That's how the ratio is of those sides. Depends on whatever one you want. You see, if you use the red one, the theorem, it's 1 squared plus 1 squared equals square root of 2 squared. That's b squared plus b squared equals c squared. So then this is 2 equals 2. So that'd be a appropriate right triangle ratio if you did 1 over the square root of 2, one side, square root of 2, and then that's equal to 1. So if you square them, then this is 1/2 plus 1/2 equals 1. So however you want to do the ratio of sides, and then you can do ratio and proportion. So however you want to set it up, what we could do, we want to solve for the side S over here, and S to 9 is the same as the square root of 2 is to 1, using, I guess, this ratio that's red, the square root of red, square root of 2 and 1. So S is going to be the square root of 2 times 9. Is that someone's phone, or is that a... Okay. All right. So you can leave it like this, or you can multiply it out, whichever way you want to do. And so then the sides, it's 9, 9, and the square root of 2 times 9. That's what they want you to find out, missing lengths of each triangle. Okay, the B part. Triangle, and this is 30, 60. Okay, so the ratio of the sides is, if this side is 1, this side is the square root of 3 over 2, and then this side is 1/2. That's the ratio of those sides.
Goes back to that diagram you gave us, with the sines and cosines.
Yeah. Okay. So they're going to give you this side, this is 20 centimeters. And they want to know, what we have to calculate is the side C and the side B, if you call this one A. So what you can do is just set up the ratio and proportion. What you don't know is C. And C is to, and whichever way you want to do it, if you want to go C is to 1, as 20 is to the square root of 3 over 2. Or you could set your ratio up as C is to 20 as 1 is to the square root of 3 over 2. However you see it. See, if you look at it this way, 1 is here, square root of 3 over 2 is here. So then it's C is to 20. Or else you're just going C to 1, which is this, as 20 is to that, and then solve it. So C is going to be 2 times 20 over the square root of 3. Now that's going to be a decimal. What would be most appropriate is to rationalize your denominator and get that. And what I did was square root of 3 over square root of 3, right? So this would be the best answer to get. But you could multiply it out and get whatever value you felt appropriate. Okay, then the next one we have to do 1/2. So what you could do is we know C. C is 40 square root of 3 over 3, and what we want to calculate is B. So we could go B is to 40 square root of 3 over 3 as 1/2 is to 1. And then B is going to be 1/2 times 40 square root of 3 over 3. So this is going to be 20 square root of 3 over 3. And that would be, we would have calculated then the sides that are not given to us. $16. This is an isosceles trapezoid. So I'm going to try to make this. These legs are supposed to be. That should be parallel. Those legs are supposed to be equal if it's isosceles. And then it's lettered P, Q, R, S. And then they give us this height. That's supposed to be right angle. And then they're giving this 8 inches. And they're giving this 6 inches. And then this side equals this side. I haven't drawn it so that it appears that way, but that's what it's supposed to be. And so, we can do, this is 6 too. Calculate the perimeter and the area of the trapezoid. They're giving us this is 45 degrees. Now it isn't very good perspective, But if this is 45 degrees, this length is 6. Right? And then this length is 6. And then all we have to do is calculate the length of this side. Well, we can either, it's going to be that C is going to be the square root of 2 times 6. So that's what this is going to be the square root of 2 times 6. 2 times 6. So now we can figure the perimeter by just adding up the distance around the side. Now this is 8 inches. So this total distance here has got to be 20 inches. So it's going to be, the perimeter is 8 plus 20 plus 2 times square root of 2 times 6. So that's going to be 28 plus 12 square root of 2. So that should be the perimeter. And then you can calculate that out, rounding it out if you want. And then the area equals 1/2 base 1 plus base 2 times the height. So it's 1/2 of 8 plus 20 times 6. So this is 14 times 6. What is that? 84 centimeters squared. Is that, no, inches squared? So that should be the area. And then I guess this is the one that's has simple form, and this is just inches. All right. 18 says find the area of an isosceles trapezoid ABCD if the bases measure 10 and 16 and 2 base angles each measure 60. Find the exact answer. An exact would be just like I did there. You would not put it in the calculator and round off. So. So what, if this is isosceles, then this has to be equal to this. And it says base angles are 60, so this is 60 degrees on one side. I guess I should make those things bigger. This is 10 and this is 16. We have these heights. And we want to find the area, so we got to find the height. So if if this is 16, the distance from here, the distance from here to here is 10, right? So that means this distance and this distance has got to be half of 6. 10 minus 16 minus 10 is 6. Each of them have to be on each side. So there's got to be equal amount on each side. Now then, with that information, we can calculate the height. And this side, if you take 1/2 of this height, you should get 3, because that's the way the ratio is. So the height equals 6. In that 30, 60, 90 triangle, this is, the ratio is 1/2, so that's how you do it. So then the area is 1/2 base 1 plus base 2 times the height. And then it's 10 plus 16 times 6. Is that 13 times 6? 78. And that's, what is that? Units. It's inches, isn't it? Inches squared. Try to make this thing bigger.
So what was the answer to that, the area?
It's supposed to be 78. Okay. And it's supposed to be, this one is 60. It says what we got is P, Q, R, S, and this is supposed to be 90. They say angle P is 60, so this angle right here is 60 degrees. Angle S is 45. And PS is 16. And the height is 5. So we have basically this is going to be a height 2, and it's going to be 5. And we want to find the area. Well, we can, because this is a 45-degree angle here, these two sides have to be the same. Right. Now, this side right here is going to be it's, you can actually do a ratio like this. You could say, you could call this side A, and you could say A is to 5 as, no, 5 is the square root of 3 over 2, and A is 1/2, right? Because the ratios, as you go around here, this is 1, and this is the square root of 3 over 2, and this one's 1/2. So you could set it up that way, and then solve for A. It's going to be 1/2 times 2 over the square root of 3 times 5, which is 5 over the square root of 3. So that's the length of this one. And let me see, what do they want? They want to find the area. Area. So we have to figure out, let's see, we have to figure out this length right up here. This length right here. Well, that length, and I'll call it base 2. Base 2 is going to equal 16 base, which is base 1, minus 5, and then minus 5 over square root of 3. So this is 11, 5 square root of 3. So then your area is 1/2 base 1 plus base 2 times height. 6, let's see, what did I call this one? 16 plus 11 plus 5 square root of 3 times the height was 5, right?
Is it 11 or 11 minus 5?
So this is 27 plus 5 square root of 3 times 5. That would be what the area would be. In exact number form, I guess if you could round, we could round it off by putting stuff in the calculator.